Hello and welcome to the page that's not written. Page 39. There we go. Oh, you can't even see that wasn't written. Haha. Okay, so today we're going to talk about how to find the limits of functions that have some sort of discontinuities. Removable discontinuities is what we're going to focus on today. Next week we'll look at infinite discontinuities. We already kind of looked at jump discontinuities when we looked at one-sided functions, right? That limits exist from the left side and from the right side, but if that function jumps, then you may have a limit from the right side that approaches 2, while the limit from the left side approaches -1, right? If it looks something like, let me switch over here, like this, right? If I approached a parabola over here, but then on this side it was a straight line that approached here, we would say that the limit as we approach from the left side, so as we approach 0 from the left side, is equal to -1, let's say. Right? But if we approach 0 from the right side, it's approaching and it's equaling +1. So we would say the limit here does not exist because they're approaching different things. So jump discontinuities, we already kind of talked about last week when we did the graphs. Removable discontinuities is going to be today's focus, and then, like I said, next week we'll be talking about infinite discontinuities. So let's start this off. So when you cannot apply direct substitution, meaning you have a function that's discontinuous, right? And you try to plug it in and you get a point that doesn't work. Now, I should clarify a little bit what I said last time. We said that you can only apply direct substitution if the function is continuous. It's really, though, if the function is continuous at that point. Like here, I could apply direct substitution for, -3, because at -3, the function is continuous. I can even apply it at +3, because at +3, the function is continuous. But over here, it is discontinuous at 0. So that is where I can't use direct substitution. I have to use some sort of other method, right? So just be mindful of that you can use direct substitution so long as it doesn't create an undefined error. So we're going to talk today, like I said, about removable discontinuities. So what happens is the first thing we're going to look at is if you plug in C, right? You plug in what x is approaching, and it produces 0 over 0. When it does that, it's creating what's called the indeterminate form. And this form allows us a few things. Usually we can factor it out, or we can use rationalizing to get common terms out of there, so that then we could plug something in, right? We remove the removable discontinuity from the actual function, knowing that it's still there, and then we can use the other form, the determinate form of that function to figure out what we could plug in there. So with that, let's look at the first example. Let's get rid of the example from the last set of notes. Okay, so example 1 says to evaluate this limit algebraically. So again, I know that we could look at a graph and do this, and you are welcome to do that to understand what your answer should be. But you need to practice being able to do this algebraically so that you could solve them without having to use a calculator. Okay, so I have the limit is x approaches 3 of x minus 3 over x squared plus 2x minus 15. So what we first try to do is just try direct substitution and see what happens. If I plug 3 in top, 3 minus 3 is going to be 0. If I plug 3 into the bottom, 3 squared is 9, plus 2x, well 2 times 3 is 6, so 9 plus 6 is 15. 15 minus 15 is 0. So this gives me an indeterminate form, right? So what that means is I could then apply factoring or rationalization to see what happens. In this case, I'm just going to try to factor. So if I factor the top, I can't do anything. It's just x minus 3, right? Look on the bottom. Is there any GCFs? No. So then let's try using our trinomial factoring. So x squared will factor into x and x. I have to multiply to make a -15 and add up to make a +2. Well, if I have to multiply to make a negative number, I know I need one positive and one negative number. So two numbers that multiply to make -15, that if we subtract them, I get +2. So for that, I would come up with +5 and -3. Well, what's nice then is because this is an x minus 3 on top and bottom, I can cancel that out. So I'm left with a 1 on top and an x plus 5 on the bottom. This should look pretty familiar because we graphed these kinds of equations, right? And if we graph this, we would cut this out and say, that means there's a removable discontinuity at 3. So we would put a hole on our graph at 3. And then we would say there is a vertical asymptote at -5, which we're not going to talk about today yet. So now I can relook at this equation. I can say, well, what is the limit as x approaches 3 of this determinate form? 1 over x plus 5. Well, I can apply direct substitution here. If I plug in the 3, I get 8, so it's going to equal 1/8. Again, I didn't write out all the rules like we did in the last examples. You don't have to. You could, though. You could write this as the limit as x is approaching 3 of 1 over the limit as x is approaching 3 of x plus 5, and then separate that into the limit of x approaching 3 of 1 over the limit of x approaching 3 of x plus the limit of x approaching 3 of 5, and then solve each of those individually. But now that we understand how direct substitution works, it's way easier just to plug it in and go, right? So 1/8 is our answer there. Let me put that up so you can write it down in my nicer ones. There's the nicer version. Go ahead and pause that if you need it so you can get it. All right, example 2, I did a little bit harder of a problem. So in example 2, I have the limit as x is approaching -4 of the function x cubed plus 4x squared minus x minus 4 all over 2x squared plus 8x. Okay, so looking at that, let's again start by just plugging it in. If I plug in -4, it's going to be a little bit, I'm going to write out a little bit here. -4 cubed is going to be a negative number. 4 times 4 is 16. 16 times 4 is 64. Here, -4 squared is going to give us positive 16. Positive 16 plus 4 is going to give us plus 64. Oh, look, those cancel out already. Here, negative minus -4 is going to give us plus 4, and then this minus 4 constant at the end. So you can see that cancels that cancels that, so it definitely equals 0 on top. Down here, -4 squared is 16. 16 times 2 is 32. And then -4 times 8 is -32. Those cancel each other out. So again, I get 0 over 0. So it is an indeterminate form, so I can factor it. So we're going to jump in here and go ahead and factor this out. If you don't remember how to factor this top part, when you have all 4 terms starting with x cubed, it's going to be factoring by grouping. So I group this and this together and this together. And we look at this top part and say, well, what is the GCF of x cubed plus 4x squared? Well, since the x cubed has a 1, 1 and 4, the greatest common factor is 1, so we're not going to worry about that. But x cubed and x squared, the greatest common factor is the x squared. If I factor an x squared out of x cubed, that's taking away 2 of the x's, so you're left with just 1x. Again, if you redistributed this, x squared times x to the first would give us x cubed again. If you take x squared out of the 4x squared, you're left with a 4. Then we look at the second one. Well, what could I factor out of -x minus 4? There's really only one thing. I want to make that positive. So I could factor out a -1. If I do, the -x turns into positive x, the -4 turns into plus 4, and that would be my factored start version. On the bottom, we could look to and say, what's the GCF there, right? That's the only thing I can factor on the bottom is GCF. Well, the 2 and the 8 have a greatest common factor of 2, and x squared and x have a greatest common factor of x. So if I take 2 away from this 2, I'm left with 1, so I'm not worried about that. But if I take x squared, or an x away from x squared, I have 1x left over. And over here, if I take 2 away from the 8, I have a 4. And if I take the x out, well, there's no x's left, so it's just 4. Let me just finish this factoring by grouping, just so we can see it the other way. You could cancel out all the x plus 4's now, but the proper way of doing factoring by grouping is now I would take this term and write x squared minus 1, and then put the x plus 4 by itself at the end. Essentially what I did is I factored out an x plus 4 and an x plus 4 to the end and left these two pieces. And then, like I said, on the bottom we have 2x and x plus 4. Well, great. Now I can cancel here and here. And I could factor this x squared minus 1 even further if I wanted to, but it looks like I have enough to do a direct substitution at this point. As x approaches -4 of x squared minus 1 over 2x, I have this determinate form now. -4 squared is 16. 16 minus 1 is 15. And on the bottom, 2 times -4 is going to be -8. So -15/8 is going to be the solution here for this limit. Again, here is a little bit nicer of a version. You can't really see my answer there because I had to use whiteout, but it is -15 over -8. All right, one last example. We're going to look at a rationalizing example. So example 3. Example 3 says find the limit as x is approaching 9 of x minus 9 over the square root of 4x with a minus 6 outside the square root. Okay, so again, let's just go ahead and test our direct substitution, see if it works. Well, 9 minus 9 equals 0. Here, 4 times 9 is 36, and the square root of 36 is 6. 6 minus 6 is 0, so it is an indeterminate form. So let's go ahead and try and factor it. Well, the moment you try to do that, you're going to see there is no way to factor that, right? X minus 9 is as factored as it goes, and the square root of 4x minus 6 is also as best as we're going to get. So what we have to use here is our rationalizing. So I can put my x minus 9 on top. I can put my square root of 4x minus 6 on the bottom. Remember, to rationalize, what we do is we multiply wherever the square root is by its conjugate. So I have 4x and 6. Well, since it was minus 6, we're going to use plus 6. That's my conjugate. If I multiply that on the bottom, I have to multiply the exact same thing on top. Now, what I want you to do is I do want you to multiply the bottom, right? Let's start with the bottom. I'm going to multiply the bottom. Square root of 4x times square root of 4x is going to give me just 4x, right? The square roots cancel each other out. 4x times 6 is going to give me, square root of 4x times 6 is going to be plus 6 square roots of 4x. Negative 6 times the square root of 4x is going to be minus 6 square roots of 4x. This should happen. These two things should cancel each other out every single time when you multiply by a conjugate. And negative 6 times 6 is negative 36. On the top, don't factor it or multiply it. Don't do it. You're going to make yourself do way too much work. Just put x minus 9 square root of 4x plus 6, two parentheses next to each other multiplied. Well, what's going to happen then is on the bottom, because this factors, when those cancel, this becomes 4x minus 36. There's definitely some factoring that can happen there. I can factor, let me put my top part up here. I can factor out a GCF here, right? The GCF is 4. If I take 4 away from 4x, I just have x. And if I take 4 out of negative 36, I have negative 9. And now I can cancel, and I should have a determinate form now. So the limit as x approaches 9 of the square root of 4x plus 6 over 4, plugging in 9. 9 times 4 is 36. The square root of 36 is 6, and 6 plus 6 is 12. On the bottom, nothing to plug in. We just have 4. 12 divided by 4 is 3. So the limit as x is approaching 9 of that function is 3. Again, let's go in here and look at the nicer version. That is the last example. There you go. So I think if you're going to have trouble this week, it's going to be those rationalizing ones. They're a little bit tough. Just take your time, be patient with them. Remember how to do conjugates and be mindful of where the square roots are and where the parentheses are so that you don't mess those up. The only other thing that I think might pop up for an issue for some people is the factoring, right? Today we talked about how to factor by GCF. We factored how to by trinomial. We did a grouping as well. The two that I think that we didn't look at is difference of two squares and sum and difference of two cubes. So remember, the difference of two squares is something like this. If you have x squared minus 4, you'd factor that into x plus 2, x minus 2, right? If this was 9, then we'd have x plus 3, x minus 3. If it was a 16, x plus 4, x minus 4, and so on. Cubes are the ones that I think we don't see as often, right? What if I did x cubed plus 8, and I'll do x cubed plus, minus 27. So remember, the factor difference of two cubes, I call it the little big factoring. You're going to do a little parenthesis that can fit 2 things, and then a big parenthesis that can fit 3 things. And then same thing here for difference of 2 cubes. So sum of 2 cubes and difference of 2 cubes, you do little big. What happens is whatever sign is here is what goes in the little parentheses. So since this is a plus sign, I put a plus sign here. Since this is a minus sign, I put a minus sign here. Over here, since there's 3 things, we need 2 signs. The first sign is always the opposite of whatever you already used. So since I used a plus sign, this one will be a minus. Since I use a minus sign, this one will be a plus. And the second sign will always be a positive sign. That never changes. So if it's plus, you'll have plus, minus, plus. If it's minus, you'll have minus, plus, plus. And what we do is for the first part, you square root. So here, cube root. The cube root of x is x, and the cube root of 8 is 2. Here, the cube root of x is x, the cube root of 27 is 3. Over here, you take these things, and for putting them on the ends, you square them. So x squared is x squared. 2 squared is 4. So I took x and squared it and put it in the first part, took 2 and squared it and put it in the second part. Same thing here, x squared and 3 squared is 9, so 9. For the middle term, you just multiply. X times 2 is 2x, so I put 2x there. X times 3 is 3x, so I put 3x there. And then you'd want to check to make sure, does this factor or does this factor? If they do, you'd have to keep going. But if they don't, then you're done. And that would be your difference in sums of cubes. So let me know if you have any questions. Good luck. Have a great week. Bye.